A couple is planning to have 4 children. Construct the sample space for the possible outcomes using B for boy and G for girl of 4 children. Then answer the questions that follow. Give probabilities as simplified fractions. Okay, we first need to write the sample space. This couple will be having 4 children. First child, second child, third child, fourth child. The first child could be a boy or a girl. We're going to use a tree diagram. The second child could be a boy or a girl. The third child could be a boy or a girl. And then the fourth child could be a boy or a girl. This gives all the possible outcomes, including the particular order in which you can have these 4 children. If we follow the first path, we would have a boy first, then another boy, then another boy, then another boy. That would give us 4 boys. So our sample space, S, and I'm going to list just all the possibilities straight down. That first path gives us boy, 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 boy. Let's follow that same path until at the end where we would have a girl. Be boy, 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 girl. So another possibility for children, boy, 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 girl. If we follow even another path, now we can cancel these off as we have them. Those are the 2 possibilities. It would start with a boy. All right, then it would be another boy. Okay, but then we go to a girl and then a boy. So it'd be boy, boy, girl, boy. So that would be that path right there. And now I'm just going to list the rest of these. I would just continue to do this until I have all possible outcomes. Okay, here I've listed all 16 possible outcomes, following all of those paths. That would be our sample space, and usually that's in a curly brackets. We can list them separated by commas in curly brackets. B, what is the probability of exactly 3 boys out of 4 children? So we need to find all of the possible outcomes where there are 3 boys. Here's 1, here's 2, here's 3, here's 4, and those 4 are all we can find. So for A, probability of exactly 3 boys is 4 out of 16, or 1/4. B, What is the probability? Oh, that was B. I'm sorry. C. What is the probability of exactly 4 girls? So let's go look at our list. And we only find one case where there's exactly 4 girls at the very end. So probability of 4 girls is 1 out of 16. D. What is the probability of exactly 1 boy? So let's go find all the scenarios or outcomes where there's 1 boy. Here's one. Here's another one. There's another one. There's another one. 4. So 4 out of 16. Or 1/4. Refer to the sample data for pre-employment drug screening shown below. If one of the subject is randomly selected, what is the probability that the test result is a false positive? Okay, we need to know the total number of people in this test. So one thing we do is we add information to our columns and our rows. We add totals. So let's add across 35 and 15, that's 50. That's saying 50 subjects use drugs. 20 and 40 is 60. 60 subjects do not use drugs. That's a total of 110. Let's add vertically. 20 and 35 is 55. 55 of the subjects had a positive test result, and 55 of the subjects had a negative test result. So half and half. But some of those are false positives, and some of those are false negatives. So the false positive would be where the test is positive, but the subject doesn't use the drug. That's called a false positive. So what is the probability of a false positive? Well, there are 20 false positives out of a total of 110 subjects that were tested. So 20 out of 110. And here we don't have to simplify the fraction. It asks for 4 decimal places, which is approximately 0.1818. And we can think of that in terms of percent, and it would be approximately 18.18% are false positives. So we could then state that there's a 50% chance of a positive test result, but there's an 18.18% chance of a false positive. All right. Use the following results for marijuana use, which is provided by a certain drug company. Among 150 subjects with positive results, there are 30 false positive results. Among 200 negative results, there are 20 false negative results. A, construct the table using the information, and then we'll get to B after that. So we need to construct a table, and what we'll do is we'll have uses the drug and then does not use. Then over here, we'll have positive test and negative test. Some of the numbers given are referring to totals. It says, among the 150 subjects with positive results. That's the total positive. There are 30 false positives. Well, a false positive would be a positive test, but the subject actually does not use the drug. So 30 goes here. What's left is 120. So there's 120 true positives. Among the 200 negative results, that's down here, there are 20 false negatives. So a false negative would be a negative result, but actually uses. So that goes here. What's left? 180. So there's 180 true negatives. We need the totals across as well. 140 use the drug. 210 do not use. Adding that last column or adding that bottom row, you get 350. So now we know there's 350 total test subjects. All right, now let's look at our question. If one of the test subjects is randomly selected, find the probability that the test subject or that subject tested positive or used marijuana. Okay. So probability, this is B, test positive or uses is going to equal probability of a positive test plus probability uses minus probability positive and uses. So if the sets are not disjoint sets, you have to subtract any overlap. So our positive are all of these. Uses are all of these. You can see, though, that we end up counting those people twice. So here's how we write our answer. It equals probability of a positive test, 150 out of 350, plus the probability that the subject uses, 140 out of 350, minus the 120 people that got counted twice. That's going to give you a 180 out of 350, which as a decimal is 0.5143.